Hello and welcome to the expert timing tutorial. This is going to cover a bit more complicated stuff than the advanced timing tutorial. This tutorial assumes that you've already gone through the single, multiple, and variable BPM tutorials from the advanced, as it's going to cover things building off of those ideas. Now the first things first, I'm going to cover this. You probably already know how to do it if you went through the variable timing, but this is a very important precaution to make sure your timing is polished and good, and that is lining up sections. A lot of times when you're adding tons and tons of sections, things will get off by a few milliseconds, and timing sections won't line up with each other. This is where the bottom left of the screen is really important. So let's say I have a very complicated timing right here. What I need to do is I need to make sure that each section moves into the next on the same millisecond. So what I do is I approach the first section from the left and look in the bottom left. Right now this is 524. That seems about right. Then I move to the right and compare it with that. If they're the same, that means that the timing here is smooth. Okay, I move on to the next one. Check this one. They're both 985. 385, 385. 599, 599. Make sure you have a smaller snap divisor than the number of timing sections there are, just so you don't like skip a timing section. 829, 829. 051, 051. 301, 301. 729, 729. 209, 225. Okay, here we have an inconsistency, and actually if I zoom in, you can see that these timing sections are indeed not lined up. This is usually not good, because this means we're resetting the timing here. And considering that this song sounds pretty consistent, it's not actually supposed to be a reset, so I need to make sure that this is properly timed. So I'm going to line it up with the previous, and I'm going to make sure that that works with the next part. Spoiler, it does, 880, 880, because I rigged this beforehand. Haha! But in principle, this is very important to do, to check over your work once you're done timing with multiple or variable. Okay, next up is something that you should know about. It is rounding error. Basically, every single section in OS is rounded to the nearest millisecond. Now, the way beats per minute work is, mathematically, they use decimal places. So what's happening is that every time you place a timing section or inheriting section, it will snap to the nearest millisecond, causing it to lose its decimal place. This constant loss of decimals will often cause timing to shift by solely adding timing sections. For instance, I've got two timing sections here. They both line up with each other and they're meant to work with each other. This is 22 and 22. These two timing sections line up perfectly. Now let's say I start adding some timing sections on time. Like I'll add one on a red tick, and then I'll add one on another red tick, maybe add one on a white tick, another white tick, another red tick, way over here, why the hell not, right in here. Alright, so I've added a couple sections that theoretically should have been on time. However, when I go check the timing section that was confirmed to be correct, it is now off. In fact, it is exactly 6 milliseconds off, just because of the rounding error that was caused by these sections. That really stinks, and honestly that makes it kind of difficult to time certain sections like that. That little badink was Deacon talking to me about a map. He's cool. In other news, the problem is that we need to avoid the rounding error somehow. And by doing that, there's a really cool way to do it. We can instead add timing sections backwards. This basically guarantees that the timing sections will be always referencing this very first section. So we won't have to worry about being completely off in that regard. So what this will mean is that we do have to actually change the BPMs in order to line them up again. So now that I've added them backwards, I'm going to check and see if there were any rounding errors happening, and I will fix them by changing the BPM of the sections. So there's no rounding error here, no rounding error here. Here's a rounding error. This section is actually going too fast now, so I need to slow it down a minuscule amount until it moves over to 22. There we go. Then I need to check this one. which has no error. This one, no error. This one, no error. This one, no error. So basically, I was able to add these sections while avoiding rounding error by making sure that this is slow enough to wait 1 more millisecond longer to compensate for the rounding error. So in short, I build the timing sections from back to front, and then I tweak them depending on whether they line up with each other or not. It's very frustrating that rounding error exists, but it is avoidable. Okay, next up is something I like to call damaged sections. It's where the timing should be consistent, but some instrument or some vocalist in between makes it not so. Here's an example. Basically, these two timing sections line up with each other perfectly and fit how the music should go. But for some reason the piano isn't snapped properly. That's a problem. So what I need to do is I need to add a section where the problem is starting to happen and add a section at the end of the problem. This will guarantee that I have 2 points that are on time no matter what. Now I have to start figuring out where the problem is. I hear it right here. So I'm actually going to go ahead and move it over here. Yeah, the piano isn't nearly going quick enough here. So I'm going to actually have to add this section and speed it up. That feels right about 13925, something like that. Alright, so now that I've repaired that piano beat, I need to fix it up for the section that we know is on time. So I'm actually going to have to slow it down radically again. Check your work. Always check your work. I'm off by 2 milliseconds. There we go. Okay, so now if I listen to this, I should have repaired in between this 130 and that 130 with this 139 and this 121. And that's exactly what happened. Repairing is very important for weird instrument hokey pokey that doesn't actually make sense. Tap, 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 tap. This part's going to be majorly talking. Lots of talking here. This is going to be about learning the inconsistency of bass, which is how sound works in OS, and the engine of OS itself. Now, unfortunately, sound in this game isn't absolutely perfect. There's a bunch of inherent flaws that are happening with things. For instance, this timing window right here, the metronome isn't actually programmed, as far as I can tell, to play with the music. It's instead programmed to play when the ball passes over the little dot. This means that that sound is linked to whatever frame rate you're currently running with your PC. I verified this by turning on frame limiter and listening to how off it is. This means that your FPS is extremely important when timing. This also goes for objects placed on the ground. They don't play until they're crossed over. So, what this means is that you want to get the highest frame rate possible in order to have the most accurate division of milliseconds possible. Let's say I want to have 1 millisecond accuracy. Since there's 1,000 milliseconds in a second, I'm going to need a frame rate of 1,000 to get that perfect millisecond sound. So right now, when I'm recording with Fraps, I have a frame rate of about 180, which means that I'm going to have some problems. If I get out a calculator and I do 1,000 divided by 180, this means that during this recording session, my sound will be up to 6 milliseconds off, which means that if I am to listen to the song properly and time it with this frame rate, I'm going to have to listen to the same section over and over again. The reason for that is sometimes it'll sound 6 milliseconds early, and other times it'll sound 6 milliseconds late. That's really annoying to have to deal with timing, so it's very, very important to have a high frame rate. So let's say you have 1,000 frames per second. That's awesome and you're having a blast. The playback rate function in the bottom right is a very scary little guy, and this is caused by bass's inherent inability to slow down songs properly. Basically, bass is really good at 100% speed, but when you slow things down, it starts to get inaccurate. This is why you have to listen to things over and over again when you're slowing down the playback, otherwise you won't be completely sure that you are on the right time. So to sum it all up, the higher the frame rate, the better. You really want 1,000 frames per second. Any less and you'll start to have inaccuracies in hearing. If you can't reach 1,000 frames per second, you can listen to the same beat over and over again until it's both early and late in different run-throughs. And if you're using the slow down playback rate to try and get that perfect sound, even if you have 1,000 frames per second, it will still be slightly inaccurate, so you do have to listen to it over and over if it's slowed down. I just finished talking about the importance of a high frame rate, and so now I'm going to try and show you how you can get a good frame rate while timing. Now here's an example of a frame rate disaster. I'm in the timing window right now, and with Fraps running, everything disabled, I'm only getting about 100 frames per second. Now it's going down to 60. All of these things are making it laggy, mostly these flags up here. The first thing you want to do to make sure you're having a good frame rate is to turn off frame limiter. Make sure it's unlimited always. Do not time with frame limiter. Do not time with frame limiter. It will mess you up so bad. So sad when people time with frame limiter. They get off by up to 17 milliseconds. They are off by that much, and it's a real sad thing to see. The next thing you should do is get rid of any inheriting sections that you have. Inheriting sections are not relevant to timing. Back them up if you have to. I just got rid of them on this map. So now if I play, I'll have a slightly higher frame rate, 190, not very much though, because there's still a bunch of sections up here. These little displayed flags are actually inherently laggy. I think they were programmed in as like an afterthought of a visual thing. They're transparent, they overlap each other, and they lag so hard. So you can actually avoid that by zooming in. I don't know who made this so you can zoom in infinitely. I think it was Walk, but whoever did, thank you so much, because now I will stop lagging. So I can increase the timeline zoom and zoom in as much as I need to. And now only 1 or 2 flags or no flags will display at once, causing the frame rate to take a huge jump. Now, it might not be completely apparent because I'm recording with Fraps, but if this were any other case, I'd be hitting at least 800 frame rate at this point. If this still doesn't work, what you can do is you can turn on the low-end PC settings in the Settings tab, the Options tab rather, or you can lower your resolution to something much smaller so your actual computer doesn't have to render as much. To reiterate, zoom in on the timeline window, turn off frame limiter, delete the inheriting sections, and if that doesn't work, lower the resolution or turn on low-end PC mode.